This is the 2005 Frappy Problem 4 that we're assigning for practice for the test on Tuesday. If you read through the stem of this problem, you can see first of all that they're asking for statistical evidence. We know what evidence means to do. It means to carry out a hypothesis test where we start with a ho and a ha. Now initially you might have difficulty determining what type of hypothesis test this is because we have learned two types. This is an example of one where you can see that there's a claim made about a percent. And so this is going to be a one proportion z-test. So you want to look back at the examples that we did regarding one proportion z-tests. Okay? Another one that we have that we'll be working on here today is the 2009B question 5, but only part A. And this one comes right out and asks you to perform a test of significance. So you know there's going to be a ho and a ha and so on. The question might be, what's this about? Is it about means or is it about proportions? And you can see that they're talking about the mean number of fluid ounces, so we can tell that this is a t-test for means. So you want to look at the example we've done regarding t-tests for means. Finally today we're going to be working on the 2006 Form B question. And this one's a little unique. Basically, if we read through this one together, you see the developers of a training program designed to improve manual dexterity claim that people who complete the 6-week program will increase their manual dexterity. So they take a random sample of 12 enrolled in the training program, and a measure of each person's dexterity on a scale of 1 to 9 was recorded just before the start of and just after the completion of the 6-week program. And so here's the data, and they say, can you conclude that the mean manual dexterity for people who have completed the 6-week training program has significantly increased? Again, they're giving me a direction. And note it says, provide appropriate statistical evidence. So that again means it is a hypothesis test. Now what's unique about this one is that it's a matched pairs t-test. It's about means, not about percents. So if it's a matched pairs t-test, we're going to have to do a little calculating to get this started. If you put the before the program values in list 1, put the after the program values in list 2, and then in list 3, enter the formula L2 minus L1, then any of these values in L3 that end up positive show improvement. Any of these values that end up in L3 that show up negative means that they did not improve, but rather did worse. So you're going to need to do one var stats of L3 after you've dumped that formula in there to get your sample mean and to get your sample standard deviation. And then you'll be able to use those to run this test. Just like we've talked about before, in a matched pairs experiment, we make the claim that there's no difference, no improvement. So that would say that mu is 0. And in this case, we want to see if it's increased, so we'd say that mu is greater than 0. Once you define mu and identify your statistics that you get from L3, you're ready to move on to step 2, the plan.